which procedure takes place in the evaluation of stars? Stella? What is the procedure happens inside the core of the star? Nuclear fusion. So because of the nuclear fusion, from the lower atomic atoms to higher atomic atoms were produced. So that kind of evolution is last class. So now we are moving on to Hertzsprung experiment. So already we learned about classification of stars from above. So depending upon the temperature, luminosity and color of the stars are classified into many types by the theorem MK theorem. So same here. So we have classification of stars on the basis of Hertzsprung diagram. So draw this graph. Depending upon the temperature, luminosity and color, we are classified into 7 systems like O, class A class, B class, M class. Do you remember that? ஞாபகம் இருக்கா? Last class பார்த்தோம்ல சேம் அதே தான் இங்கேயும். ஸோ இங்கே என்ன பண்ணிருக்காங்க அப்படின்னா தியரிட்டிக்கல் எக்ஸ்பிளனேஷன் இல்லாம கிராஃபிக்கல் எக்ஸ்பிளனேஷன் கொடுத்துருக்காங்க. ஸோ லிசன். ஸோ ஆல்ரெடி உங்களுக்கு தெரியும். ஸோ திஸ் இஸ் த கிராஃப் பிட்வீன் temperature and then luminosity. This is the luminosity of sun value and this is temperature which is measured in Kelvin. So this is 30,000, 20,000, 10,000. So and so going on up to 3,000. So in y-axis we are taking the luminosity of the sun. So இப்போ theoretical value எடுத்து வச்சு compare பண்ணு. Take the notes. Classification of stars எழுதிருக்கல எடுத்துக்கோ. So first class O class O ல என்ன எழுதிருக்கோம்? What is the temperature of class O? 20,000 to 30,000. So that is 25,000 to 30,000. Which has the temperature, which has which color? In the color mention bluish white. So Allah is right, bluish white. So color company irundhuchu appadina color draw பண்ணிக்கலாம். Another color mention பண்ணிக்கலாம். சரியா? So and then next class is B class. Next class is B class. So B class is which color? White color. So bluish white to white and which have the temperature value of 10,000 to 7,000 up to etc. So last வரும்போது என்ன கலர் வரும்? Red color. So this is the graphical representation. அது theoretical representation. Same அதே நம்ம என்ன எடுத்துறோம்? Graphical representation கொடுத்தது என்னது? Hertzsprung diagram. So இது நீ நோட்ஸ்ல பார்க்கறப்ப அவங்க கலரா மென்ஷன் பண்ணிருப்பாங்க. This is red color ball, orange color ball and this largest ball which is written as L is the sun. So you already know that what is the value of luminosity of sun is 1L which is yellow in color and having the temperature of 6,000 Kelvin. You already know that. அதனால sun ஓட என்ன பண்ணிருக்காங்க அப்படினா ஹைலைட் பண்ணி காமிக்கலாம். சரியா? So இந்த டயகிராம் டிரா பண்ணிக்கோ. This is just the classification of stellar on the basis of graphical representation. சரியா? So next topic is luminosity of star. So what is luminosity? What is luminosity? Luminous is nothing but how bright it was அப்படின்றத என்ன சொல்றோம் luminosity. So how bright the star it was அப்படின்றத calculate பண்றது. So already know that the value of L. So L is nothing but luminosity of sun which is 3.84 into 10 power 26 watt or Joule second power minus 1. So this is the value of luminosity of sun. So it is also denoted as, put a single dot inside the circle. So 3.84 into 10 power 26 watt or also measured in Joule second power minus 1. So here we go. So L is a measure of, L is nothing but luminosity. So luminosity of star. So why we are taking sun? Sun is also a star. So N is a measure of total amount of energy radiated by the star. So luminosity is dependent upon the two factors. So first one is temperature and second one is size. So if temperature increases, what will happen to the luminosity? If temperature increases, what will happen to the luminosity? So luminosity is the energy. So temperature is thermal energy. If thermal energy increases, luminosity also increases. When we are comparing two stars, like one is a bigger star and another one is smaller star, so which lower must higher? If you are taking two stars, one is smaller in size, having small surface area, and another is having larger in size, having large surface area, which star is right more? Largest star. So the temperature and size is always directly proportional to the luminosity. If temperature increases, luminosity also increases. If temperature decreases, luminosity also decreases. Likewise, if the size of the star is smaller, luminosity is less luminosity. If the size of the star is larger, it has high luminosity. So temperature is depending upon the L is nothing but power radiated, directly proportional to the T inequality. So L which is equal to sigma T power 4. So sigma is nothing but Boltzmann constant. So this is the basic formula. So the power radiated L which is directly proportional to the fourth power of its temperature. So proportional equal to constant put that constant is called sigma. So sigma is Boltzmann constant. The size, there we go. If two stars having the same effective temperature, but one is larger than another, so what it means? The size of the two stars may be varying. So the star with the greater surface area must be more luminous than the smaller one. So what are the two factors which leads to the luminosity of star? First one is temperature and second one is size. Both are directly proportional to the luminosity. If both factors increases, luminosity also increases. If both factors decreases, luminosity also decreases. Now luminosity depends upon the factor, temperature and the size. Now page 7. The next topic is binary star. The name itself, the meaning is there. So what is binary? Two. So two stars are combined together by the gravitational force and it has a common central axis. So that we know binary stars. There you go. A system is gravitationally only two stars is said to be binary stars. These two stars are gravitationally attached with each other and it has a common center of mass. So what is center of mass? If you are taking two objects having the same mass, m1 and m2. For example, if you are taking two balls which has same mass, so where the center of mass will be? What is center of mass? How will you keep equilibrium position of these two masses? So எங்க center of mass இருக்கோ அங்க பாயிண்ட் பண்ணி நம்ம place ஹோல்ட் பண்ணா மட்டும் தான் ஆப்ஜெக்ட் என்ன பண்ணும் ஸ்டேபிளா இருக்கும். So if you are taking two objects having equal mass, where the center of mass will exist? At the center of the two objects. ஓகேவா? இப்போ ஃபார் எக்ஸாம்பிள் நம்ம பால் எடுத்து நோட் எல்லாம் என்ன பண்ற? ஒரு சிங்கிள் ஃபிங்கர் டிக்ல என்ன பண்றோம்? ப்ளேஸ் பண்ணி ரொட்டேட் பண்ற. ஆமாவா? சோ அப்ப நமக்கு எப்படி தெரியும்? The mass is same in all the places. அப்ப center of mass எங்க எக்ஸிபிட் ஆயிருக்கும்? At the center. If you are taking only equal masses. If you are taking two masses, one is larger and another one is small, so where the center of mass will exist? For equal mass, the center of mass will exhibit at the center. I am asking if you are taking a mass of larger one and then smaller one, where the center of mass will exhibit? Towards the larger one. So the center of mass will exhibit towards the larger mass. If you are taking smallest mass and largest mass, which is m1 and m2, where is the center of mass will exhibit? Towards M2. So towards the object D. Same அதே மாதிரி தான். So binary stars it consists of two stars. One star is larger and another star is smaller. So depending upon the size of the star, the center of mass will exhibit. So here there are two orbits are there. The first orbit is circular orbit and second one is elliptical orbit. So listen, in circular orbit if you are taking a smallest mass which is rotating around the smallest axis, and if you are taking the largest mass star which is rotated in a larger orbit, there is a center of mass will exhibit between the star A and B. So where is the center of mass will exhibit? Towards A or B? Towards A is the smallest star having small orbit. B is the largest size star having largest orbit. Which is larger? B is larger. But where the center of mass will exhibit? B. Towards B. Towards B. So same here. If you are taking smallest star having elliptical orbit and largest star having an elliptical orbit like this, so where the center of mass will exhibit? Towards A or B? Towards A. Simple. So the center of mass will exhibit towards the largest mass of the star. Very good. Same brightness and same temperature. So in the way example about one has larger mass and another one has smallest mass. So the largest mass star is called, when a place of it, the largest star mass is called primary star. The one having smallest star mass is called secondary star or companion star. Have it clear? So binary star is nothing but a system consists of only two stars which is bounded gravitationally and it has a common center of mass. The larger mass is called primary star, the smaller mass is called secondary star or companion star, and there are two orbits exhibit, one is circular orbit and another one is elliptical orbit. Yeah, third bench எழுதுறியா என்ன பண்ணிட்டு இருக்க? Types of binary stars. Write it down. Types of binary stars. So first one is visual binary stars. Visual binary star. என்னதான் நடந்துட்டு இருக்கு செகண்ட் பெஞ்ச்ல லாஸ்ட் டே என்ன வேணும் எழுதுனியா இல்லையா the first type is visual binary star second one is spectroscopic binary star third one is elliptic binary star elliptical shape சொல்லுங்க elliptic binary stars and fourth one is astrometric binary stars variable star so listen if you look up to the sky some stars are brighter on one day and another day the star will be less brighter some star is present on another day some star is absent so what is the reason behind that star means that is called variable star there is a change in the physical property of the star is called variable star so each star has its own brightness luminosity temperature size ஆமாவா so இந்த physical property change ஆகறத நம்ம என்ன சொல்றோம் variable star சொல்றோம் so எழுதிக்கோ a variable star is simply one a variable star is simply one whose brightness or other physical property such as radius or spectral type changes over time so listen the property of the star maybe changes from a day to millions of years so adha nam enna panna porom appadina variable star la paaka porom so classification of variable star so write this flow chart carefully Extent is nothing but outside. So in this instead star, the changes, physical changes occurs within the star, and external phase of Antarctica changes occurs out of the star. So what is variable star? Variable star means there is a change in physical properties like luminosity, temperature, size. And then we have variable star. So the changes occurs inside the star by extending. If the changes occur outside of the star, then it is called extending. So extending is classified into two classes. First one is pulsating star, and second one is variable star. So listen, pulsating star is depends upon only the size of the star, but eruptive star depends upon the luminosity. Okay, here the physical property changes with the size. Here the physical property changes with the luminosity. So here there are so many types of that we will discuss. And then in the extending variable, so there are two types: increasing binaries and then rotating variable. You already know that increasing binaries. So what is binary stars? Two stars are combined by the gravitational force and having the common center of mass. So the orbit one orbit is overlapped with the another orbit, so which is called ellipsing binaries, and rotating variable is nothing but each sun and each star has a sunspot or star spots are available. Each spots are rotating, the sun is also rotating, that leads to the change in the physical properties. So here there are so many types of having pulsating star. So here we go. So for C5, the magnitude of brightness is flow chart எழுதி சொல்லு எழுதியா என்ன இல்ல ஏய் ரோட்டா brightness changes over a period of time. So here we are given a period of time and then magnitude of brightness value. So for type 1, the changes occurs within 5 to 10 days, and the magnitude of type 1 class is 0.5 to 2. This is the magnitude of brightness value. So magnitude is nothing but it is a constant one. Value numbers, the numerical values are magnitude. Magnitude. This is the magnitude of brightness for class 1. For class 2, the change is over a period of 1 to 30 days, and the magnitude value which is 0.3 to 1. So for the case of RR rays, the changes occurs within 1.5 hours, and the magnitude of brightness will be 0.3 to 2. When a second is light, where light? Natural. We get information from me. So RV towering, the changes occurs 20 to 100 days, and the magnitude of brightness will be Yes. So the magnitude value for Mira is 6. For semi-regular, the magnitude will be less than 2. And number எழுதுறதுல என்ன values? Magnitude of stars, the magnitude of brightness. What is variable star? Change in the brightness. The magnitude will be changes over a period of time like days, years, money change ஆகும். சரியா? இதுவரை எழுதியா? Have you completed? So இந்த elliptic star என்ன பண்றேன் நான் தனியா ஒரு flowchart போடுறேன். இத என்ன பண்றேன்னா கண்டினியூ பண்ணி எழுதுறோம். சரியா? So like percentage star மாதிரி elliptic star 6 to 7 times இருக்கு. So அதிலே நம்ம என்ன பண்ணிரோம் period of time and then magnitude of brightness mention பண்ணிரோம் ஆமாவா சோ அதனால க்ளோஸ் கேப் டிரா பண்ணுங்க chapter stellar evaluation ஒரு 60 mark question and then classification of stars second 60 mark question. So in that part என்ன வந்துரும் Hertzsprung diagram வந்துரும் சரியா. Hertzsprung diagram is nothing but graphical representation of stellar classification அவ்வளவுதான். அது நம்ம தியரிட்டிக்கலா பார்க்கும்போது இதுல என்ன பார்ப்போம் graphical representationல பார்த்தோம். So notes பார்க்கும்போது அவங்களே கலர்ஸ்ல கொடுத்திருப்பாங்க red color star blue color star white color star you can understand easily சரியா. And then Pleiadian star is a important 60 mark question. Binary stars எல்லாமே subdivisions காக படிச்சுக்கோம் சரியா.